What's up, you freaking geniuses? So in this video, let's go over a combined variation word problem, all right? And just as a quick reminder, combined variation just means you're going to use both direct and inverse variation, okay? So the formula for a direct variation is just y is equal to k times x, and the formula for an inverse variation is y is equal to k over x. Okay, and just a heads up, some books use a instead of k, all right, but they mean the exact same thing. All right, so now let's read our word problem right here. So it says a gas law states that the volume of an enclosed gas varies inversely with the pressure and directly with the temperature. The pressure of a gas is 0.75 kilograms per square centimeter when the temperature is 294 Kelvin and the volume is 8,000 centimeters, all right? So now we're asked to find two things. So the first one, part A, just says write an equation relating pressure, temperature, and volume. Okay, so let's start there. Let's start with part A. So what does our first sentence tell us about the pressure, temperature, and volume? Well, here it says that the volume of a gas varies, okay? So the volume, we want to find the volume, right? And let's label that as V. And then we also want to find the pressure and temperature, right? So we want to find the pressure, let's label that as P, and the temperature, let's label that as T, all right? So again, the first sentence just says that the volume varies, okay? Whenever you see varies, that means you're going to plug in an equal symbol, all right? So here we're saying that the volume is equal to something, all right? So then our combined formula is going to be something like the volume is equal to something, all right? What's it equal to? Well, it says that it varies inversely with the pressure. Okay, so if it varies inversely, then we're going to use this formula over here, right? So we're going to have a fraction, so we're going to have k over some number, right? So the volume is going to be equal to k over some number, which we don't know, right? We just know it's the pressure. So let's just label the bottom as P, okay? And then it also tells us that the volume varies directly with the temperature, okay? So then you can see that we're going to place the temperature in a direct variation, right? So it's just kind of straight across. So then here we're going to put a T on top. So things that vary directly go on top, and things that vary inversely go on the bottom. Okay, great. So now this is kind of the first part to the first question, all right? We still have to finish it. And the way that we do that is by using these numbers that it gave us, right? So it says that the pressure of the gas, so P, is equal to 0.75 kilograms per square centimeter. When the temperature, so then we know the temperature is 294 Kelvin, and the volume is 8,000 cubic centimeters, all right? So we're gonna plug in these three numbers that it gives us into our combined variation formula, and it's gonna help us solve for K. All right, so again, the volume was 8,000, and we're gonna say that's equal to K times the temperature, which is 294, and we're gonna divide that by the pressure, and the pressure is 0.75. So again, we're trying to solve for K, so the first thing we can do is get rid of this 0.75 by multiplying both sides by 0.75, right? So then those cancel out. And over here we get 6,000 is equal to K times 294. Now here we can divide both sides by 294, like so. Those cancel out. And here we get that K is equal to 6,000 divided by 294, which is equal to approximately 20.41. So as you can see, our answer here is just an approximation. We're just rounding. That might not be the best method unless your teacher's cool with it, but in case they want an exact number, then we have to leave it just as a fraction, okay? This is an exact number. Okay, so in this case, I'm going to leave it as an exact number. So let's just write it up here for reference. K is equal to 6,000 over 294, all right? So now that we've figured out what K is equal to, let's just plug it back into our formula over here. So then we can finally write that the volume is equal to 6,000 over 294 times t, and that's all over p. Okay, now it's a little strange seeing this fraction within a fraction, so if you want, you can actually just factor this out to the front. So here we could say that the volume is equal to 6,000 over 294, and then on top we're left with t, and on the bottom we're left with p. Okay, so as you can see, we're basically just multiplying two fractions together. So here we could simply say that the volume is equal to 6,000 t over 294p. Okay, and it's normally good to check if you can actually reduce your fraction over here, which in this case, I'm just going to tell you, yes, we can. So 6,000 over 294, that actually reduces down to 1,000 over 49. Okay, so here we could say that the volume is equal to 1,000 t over 49p. All right, that's as simplified and as reduced as we can write this. All right, so this would be our final answer for part A. Now let's do part B real quick. So part B just says, find the pressure when the temperature is 300 Kelvin and the volume is 7,000 cubic centimeters. Okay, so now that we know what the combined variation formula is, let's rewrite it so we can solve for the pressure, because that's what we're going to be looking for this time, okay? So if this is our formula, let's just write it over here. So we're trying to solve for P, right? So the first thing we can do is get it out of the denominator by multiplying both sides by P, all right? So then on this side they cancel out, and then over here we have P times V is equal to 1,000 T over 49, all right? Now to get rid of this V, we can either divide by V, or what would be a little simpler in this case, would be just by multiplying by the reciprocal, right? So let's multiply by 1 over V, and let's multiply this side by 1 over V. Okay, and the reason I chose to do that is because, as you can see, now we're just multiplying two fractions together, right? So now we can easily see what we're going to multiply just straight across. So then, first of all, on this side, the 1 over V and the V cancel out, so then here we're just going to be left with P is equal to, and then just combining on top, 1,000 T times 1 is just 1,000 T, and on the bottom, 49 times V is just 49 B. Okay, so now that we rearranged our formula, now let's use it to solve for the pressure. So let's just write it up here. So we're going to say that the pressure is equal to 1,000 times T, and the temperature is given as 300. And we're going to divide by 49V, so 49 times V, the volume is 7,000. All right, so if you plug this into your calculator, you'll get that this is equal to approximately 0.87. And what are our units? Well, the units for pressure that were given in the problem, let's see. The pressure, it says right here, the pressure of a gas is kilograms per square centimeters. So kilograms per centimeters squared. Boom. So if you found the video helpful, make sure to leave a thumbs up down below. And if you have any questions, let me know in the comments section below.